Good evening, Nano fam. Welcome, LFLF. Hey, Abdul Aziz. Hey, Anderfnal. What an exciting stream this is today. We did it, guys. We did it. We have 100% Rust node with certain limitations still, but that big milestone of having the full node in Rust, we finally done it. So that took more than 2 years of work, and it was so much fun, really. So I enjoyed the last 2 years so much, you guys wouldn't believe. Hey, Sammy D. Okay, so let me all add you to the spinner wheel first. So LFLF Underfinal, we have Sammy D, we have 1401. We have Ju. All of the old names are here. That's great. Joshua Button says, good evening, excited to learn a thing or two about Rust and NanoNode. Yeah, that's the perfect stream then. Joshua Button posted his nano address. Okay, so let me just add that quickly. So let's just do the spinner wheel first, and let's also start the timer. Yeah. Okay, so we have a new entry. Oh, I'm not logged in. Okay. Come on. Where's the chat? So here we have a new nano address from Joshua Button. So there you go, and let's add you to the wheel. So who else is in the chat? Let's check. LFLF, yeah, great work. Thanks, LFLF, and thank you for helping me publish the blog post. Illy Bob, good evening, congrats. Thanks, Illy Bob, and Pice is here, so let's add you all too. So we have Illy Bob and Illy Bob. And we have Pice. Okay, I hope I have got all of you. If you are not on the wheel, please check now that you're on the wheel. If you're not on the wheel, please just write a chat message. Okay, so Sammy D, Gustav for president, what? No. 1401 says, huge props, Gustav, very impressive work and dedication. Yeah, so thanks, guys. So thank you so much for all of the support. So the Nano community is really the nicest community out there, really. So I've got so much support from you guys. And yeah, as I said, the last 2 years were so much fun for me. Very, very enjoyable work. And now we reached the milestone. Now we have a full Rust node. So it is still a prototype. It is not releasable yet, but it just shows that we did it. We have a full Rust node now. And last Friday was the first time I could start it. And if you've seen the short screencast that I posted on Twitter, that was from Friday. So as you know, I was finishing up the last parts of the Node class, bringing all of that code to Rust. And I got that done on Friday. And then I thought, I have the Node fully in Rust. I have everything I need. I could just simply write a main function in Rust that would just start up the node. And that's what I did. And that's what you see in the video. So I drew up, I drew up the current state of the node. And I made the boxes that are, made them red, which are still missing. And the blue boxes are ported, and there are a lot more. I just was lazy. I just added a box that says much more, because there's actually a lot of blue boxes and just very few red boxes. So What is not in the node is the distributed work. So that is a class that communicates with an external work server if you don't want to create the work on your node, but you want to use a third-party tool. So that is not in the full Rust node. Also, there's no OpenCL work generation, so you can't use your graphics card yet. And there is no UPnP port mapping support, and that's really like, I don't think anyone uses it. So this is for an automatic port configuration if you are behind an NAT, if your node is behind an NAT. And I don't know if this is really used. I don't know. Also, we don't have the command line interface yet. We don't have an RPC server, and we don't have an IPC server. But what we have is we have the full node with everything a node does, with voting, with ledger, block storage, with absolutely everything, with the schedulers and so much more. And I'm so excited that we got it to this far. LF asks, how does the performance compare to the CPP version? I don't know yet. I have not tested it yet. So I was very busy just moving the code, and I kept running the unit tests, and they pass, and the RPC tests, and they pass. But I have not started the real testing yet. So we will see. And I suspect that the performance will be worse because the code is still full of inefficiencies that I added to make the porting easier. And part of my work for the upcoming months will be to remove these inefficiencies and to make it as fast as I can. LF says, I mean, you haven't optimized the Rust implementation yet, so I think there is a lot more potential. Oh, there is a lot more. Yeah, there is a lot more potential. And who knows, maybe we can beat the C++ node performance one day. So yeah, so that's the state. And let's just have a look at the prototypical main function. It's not nice, but it's just a prototype. So let's just go to the Rust folder. There I added a new project main, and it just has one file with the main function in it. And let's just scroll through this because it's just a couple of lines, really. And so it just uses the beta network. It creates the app path, the working directory, and initializes all of the configuration stuff to default values, and creates a work pool for CPU work generation. And then it just creates a node. It starts the node, and then it just waits until we hit Control-C, and it keeps running. So let's just, I think you've all seen it, but because it's so nice, let's just do it. Where are we here? Yeah, we are in the Rust main already. So let's just say cargo run release. And what it does is, there you see it. It just starts the node and it does its thing. Full of debug log messages still. That's on purpose for me to find issues with memory leaks with the sockets. Yeah, but it looks good. I'm not sure how fast it works or what it does, because I don't have access to the RPC yet, but that will follow soon. So Johnny Alstrom says, amazing work, Gustav. Thank you so much, Johnny. I think you are not on the wheel yet. Johnny, no. So let's add you here. Okay, so yeah, have you guys brought your favorite beverage? Because I'm going to open a bottle of this, just because it's time time to celebrate. Craptor, hello and congratulations on the 100% Rust node. Yeah, thank you, Craptor. Let's add you too to the spin wheel. Yeah, so let's celebrate this. And the first nano giveaway will be in 1 minute. So maybe we can... Ooh. Yeah, maybe we can cheer for the first nano giveaway. NanoFam, it's been a pleasure. 2 years of work and we have a full Rust node. Cheers, guys. Crapto says, is that beer or wine? No, it's what's the English word? Sparkling wine. 1401 says, just got a bottle of celebratory what? Meisel Helles. Oh, a good beer. That's good. I have to lower the volume of my headphones. So. Okay, and the first nano giveaway starts now. Yeah, cheers, NanoFam. Oh, did the wheel spin? Yeah, I did. Okay, Craptor, you win the first nano of tonight. Craptor. Oh, the wallet is locked. So now. Okay. Congratulations, Craptor. First nano of the night goes to you. Craptor says, didn't seem like the wheel spinned. Yeah, I looked away and then it was... But it said you won. I don't know. It's rigged again. It didn't spin? Okay, so now I want to test spin it now. Okay, so this is not a giveaway. This is a test spin. Okay, now it spins. That's weird. Okay, it's rigged. And let's restart the timer. Rigged wheel just did 15-degree spin and said this is enough. Yeah, it's tired. Give him some time. Okay. So let's stop the node here. Oh, here it's processing blocks. Bootstrap Legacy. Cool. Yeah, so let's stop the node. And yeah, so do you have any questions or anything, any comments? Now is the time before we jump into improving the code base. Or maybe not. No, I wanted to show you what I worked on during last week. Because I think this is interesting stuff. Oh, LFLF says, where does it get the nodes from? To which nodes does the node connect on startup? So on the beta Bootstrap nodes. So it just does the usual peering process, and it connects to beta nodes. That's what I configured as hard coded in the main function. Yeah, so last week I worked on moving the nodes code to Rust, and one interesting thing that I worked on was the node ID file. So in case you didn't know, the node it creates a text file on its first start where it creates a node ID, and it uses this node ID in the network as a unique identifier for this node. And I ported that code to Rust. So let's open up that file, node ID. Here we are, node ID key file. So it creates the file on the first start, and from then on it only reads the node ID in subsequent starts, so that a node always has the same node ID. 1401 asks, what is the IPC doing in a nanonode? So it's just a short detour. There are two ways to connect to a node. One is RPC, so these are HTTP calls, and the other one is IPC, which means inter-process communication, and they both use the exact same protocol. So it's these JSON messages. It's just two different ways to do the same thing, really. So in reality, it is done like that. So RPC, I think, uses, I'm not even sure if it is like that. It could be that RPC just delegates to IPC, and IPC then delegates to the node. It could be that it is like that. I'm not sure. So these are just two ways to connect to a nanonode, and those ways are not ported to Rust yet. Why has the music stopped? Okay. Yeah, so the node ID key file, and it is not much code really. So it checks if the file is already there, then it just loads the file, and if the file is not there, it just creates a one. Okay. And I wrote unit tests for this, and this is now the interesting part, because I wanted to do this in the nullable fashion that I talk about so often. So that means I wanted to write the tests in a way that they don't actually write files and read files, but the tests, they should look like we work with real files, and that's what I did here. So let's first maybe look at the tests of the C++ code for this. So I've opened that up already here, and this is the only test. So there's just one test function for this, and it tests multiple things. And these tests are not that bad, but they work with the real file system, and that can have pitfalls. Not so much on Linux, but maybe on Windows, where I have had all kinds of strange test failures on Windows with virus scanners blocking files and other processes blocking files and whatnot. And yeah, so these are the tests here that we have in C++. And now let's switch to Rust and how I tested this code. So these are the tests. So in case you didn't know, in Rust the tests are in the same file as the production code. These are the tests, and as you can see, I wrote a lot more tests than the C++ code has. And that is on purpose, because I am very pedantic when it comes to testing, and I like to test everything, like every single line, even the logging. And I know that this is an opinionated topic, because most people don't test logging. But I do test logging because I want to test everything that can go wrong, and log messages can go wrong. So I made that mistake a lot in my career, where I messed up the formatting strings, or I had a typo in the log message. And because I typed out these log messages twice, so I don't copy paste them, that reduces the typo probability. And also it catches the formatting errors, if there are any formatting errors in the code, in the logging code. So as you can see here, let's have a look at this test here. So it initializes the node ID file, and then it asserts that we have a log message. And the log message says reading node ID from and the path. So yeah, I do that. I actually test log messages. LFLF says, that's the first time I hear of log testing. Yeah, I know. Not many people do it. And if it's okay, I mean, if it's okay if you don't do it, but I want to do it. I want to make sure that the log messages are correct. That's just, yeah, call me pedantic, but I am pedantic. Yeah, so in order for these tests to not use real files, I had to make the file system nullable. And that's exactly what I did here. So let's pick a test. Or let's have a look at the helper functions. I created a couple of helper functions here. For example, this one, initialize node ID with valid existing file. So what this helper function does is it creates a file, not a real file. In our nulled file system, it creates a file, and then it calls the initialization code. So let's have a look at the fs with key file function. And here it is. Here is the magic. I wrote this nullable file system struct. It is not much code really. I can open it up later, and we can just say that a path exists. So that means whenever we call path exists with this file path, it will say yes, true. And whenever we call read to string for this file path, it will return that content here. And that's it. That is the nullable file system. And we use this nullable file system in our production code. So this is the node ID key file. It gets in the constructor, it gets the nullable file system. And then it calls, yeah, file system exists here. And when it loads the key, it calls fs read to string. And these are just wrapper functions for the actual Rust functions that load files. Let's have a look at that. So this is the nullable file system. And read to string. Yeah, so there is two implementations inside of the nullable file system. We have the real one, so this is the real one. And as you can see, it just delegates to the real Rust functions. So read to string delegates to stdf, s read to string, create dir all delegates to, yeah, so this is just super simple, just delegating to the real functions. And then we have a file system stop implementation that just returns the configured responses. So as you can see, this is not much work to write, so just a couple of lines of code, but it enables us to test our code that works with files without having to actually use the file system. And those tests are super fast, and they are very reliable and easy to write. And I also tested the nullable file system itself. As you can see, when you scroll down here, I tested that the real implementation works, and this is the only place where I actually access the file system. So this is the only test here that actually writes files. Okay, so these two. So these are the tests for the real thing. And then we have the nullability tests here. Nullability, and they test that I can provide configured responses for all of those file system functions. yeah, so that was the first thing I wanted to show you, the nullable file system and the node ID key file code that uses it. And with this system, I could also write a lot of tests that are not in the C++ tests. For example, I have, the logging tests and also error cases. So here I test what happens if the file can't be read because of permission issues. What happens if the file can't be parsed because the file content is invalid. And yeah, also what if the directory can't be created. This test here fails if directory cannot be created. We can simulate those error cases easily, and you would have a hard time simulating those error conditions with a real file system. For example, this here says, so we say nullable file system null builder, and then we say create your all fails, and we give the path, and then we give the error that we want to return whenever we call create dir all for this path. See, that's just really easy to do, and we can simulate all types of failure cases here. And it's, yeah, without accessing the file system. Isn't that fantastic? Joshua Button says, is this testing habit something you have always had or developed later in your career? Obviously later. So I don't think anyone starts out with such a testing habit. I think the usual way you become a dev is you enjoy programming very much, and you hack along and you write a lot of code, and it's great. And yeah, then you get to learn all of the trouble you can get yourself into, like nights of debugging, many hours and days wasted with the quality issues of the code. And I mean, we all know it. We change a little thing here and the whole system breaks, and then we spend days fixing it, and then we change another little thing and the whole system breaks, and it's so frustrating. And I think that's when we as programmers learn that we have to have better quality control, like we have to have automated tests, and it was like that for me. I started programming when I was a kid. I was 9 years old, I think. And I started working test-driven when I was 20. So from age 9 to age 20 or 21, I don't know the exact date anymore. I didn't write tests. And then learning how to write good tests is also something that takes a lot of time. So the first years that I worked test-driven, I also fucked up a lot of things there. Like I wrote really bad tests. So tests that are hard to read, or tests that would fail intermittently, or if you would just make a small refactoring, all tests would break because they were too coupled to the implementation. So there's a lot of stuff to learn there, and it takes years to become good in writing tests. LFLF says you should make a crate out of nullable file system. Yeah, but it's just purpose built. It's just purpose built for what I need. So if you make a crate, you should write documentation, and you should really handle all of the cases that your users need. And my nullable file system is purpose built just for the stuff that I need. Yeah, so I don't want to have that extra work of maintaining a crate. Joshua Button says, this is the point I'm at now. Oh, so you mean the breaking of the system? But working in a high pressure environment, small team, and want to develop these quality control habits early. Yeah, so that is a very tough situation to be in. So if you are in a project that is under pressure, and you want to convince your team or your manager to switch to test-driven development and have more quality control, I think it's the right step to do, but it is just so tough because you will make a lot of mistakes when you switch to test-driven development, and it will slow you down initially a lot. And if when you are under pressure and you do something that slows you down even more, yeah, it's tough. LFLF says to Joshua Button, it's important to be consistent and persistent. Tests are not pretty. They aren't features or provide business value. So sometimes management will try to discourage you. Yeah, I've had that. Diamascu says, congrats on the completion. Been following this on Twitter and think this is a great step forward for Nano. Yeah, thank you so much. Yeah, so... Yeah, back to the original question. So yeah, I learned test-driven development in the early years of 2000s, like 2001 or something like that. 2000, 2001. And I didn't believe the claims when I started to learn it because I read in books that it would make you faster. And it doesn't feel faster. It still doesn't feel faster because you spend a lot of time writing those tests and you just know the production code you want to write. You just know, you have it in your mind, and then you have the feeling that the tests slow you down. But what you don't see is how much time it saves you later down the road when you don't spend days of debugging. And when you have a clean system and you need to add more features and you can just easily put them in instead of working with a mess and not making any progress. And that's where you save time. That's where you become faster and much more faster. And the actual coding feels slower because of the tests. But yeah. Overall, you are much faster, and I didn't believe that in the beginning, and yeah, through a lot of messes and tough projects and stuff like that, I learned that yeah, those old programmer guys are right. NaruEth, nice job on 100%. NaruEth, are you on the spinner wheel? Thanks, NaruEth. Oh, and the block timer. So let's just add NaruEth and let's give away one more nano. And cheers, NaruEth. So this one is for Sammy D. Congratulations. Okay. Woohoo, says Sammy. All right, yeah. Yeah, so my best advice, if you are in a team that has all of these issues and you want to change something and improve on that, my advice is convince management to get you someone who's experienced in test-driven development and to coach you. Because then you don't have to make all of those costly mistakes yourself. Damiescus asks, how do you get added to the wheel? Not that I mind, I've given away plenty of nano myself, lol. Oh yeah, join the wheel, it's fun. Just post your nano address in chat. Just your nano address in chat and I will add you to the wheel. Oh, okay, so that was the node-id key file here. And I also wanted to show you another part of the node where I wrote tests. Now, which one was it? Let me just, or maybe I can find out in the browser. Yeah, so here I have the tests open. No, this is the wrong one. This one. Oh yeah, the peers. So whenever we start the nano node, it periodically saves all of the IP addresses that it is connected to, and with the goal of reconnecting to them on the next node startup. So this is an optimization so that the node doesn't have to do a full peering again. So it will just periodically save the current connected IP addresses, and when we restart the node, it will just reconnect to those IP addresses. That is what in the C++ code the class peer history does. And in the Rust code, I split that up into two classes. Let's see, where is it? I split that up into two classes. One is the peer cache connector, which connects to the peers from the peer cache. So the peer cache is the stored peers in the database. And we have the peer cache updater, which periodically saves the currently connected peers to the database. And I think here we really see a difference in the testing strategy. And I believe that the testing strategy we have here is just way better. Damiascus, sweet, this is my Nano GPT wallet, so I can ask a lot more ChatGPT questions. Okay, so let's add you quickly. Add new. Oh, no, what? Not add new account. Add new address book entry. And your address is this one. Oh, I didn't. Okay. Okay. So 5 more minutes and we give away another Nano. Okay, so yeah, the peer cache updater. So as I said, this periodically updates the peer cache. And the code itself, it's not particularly interesting. It does exactly what you would think it would do. So when it runs, it just saves the current peers and it deletes the old peers from the cache. So it doesn't store them forever. And let's compare the tests. And this is now the difference in the testing strategy that I have been talking about for so long. So in the C++ code base, the tests usually use the full node. And this is the C++ test here for this peer cache capability. And it creates a full running node with everything a node has. And it does strange things here. And the test is big, like it doesn't even fit on the screen here. I have to scroll through it. Then it makes real network connections here, and it has to wait until those connections are established. That makes the test slow, and then it reads the peer cache from the real database, and it has to stop the node. And this second test is also for the peer cache, where it tests, I think it tests that after the node restart, it reconnects to the stored peers. So again, it creates a real node and it does strange things here. So I think here it puts something into the database and then it destroys the node, then it creates the node again. And yeah, a lot of code here. Again, it doesn't fit on one screen and it is slow because it works with real nodes, with real network stuff. And it's brittle. because there's so much that could go wrong here. The port could be taken and whatever. So now let's have a look at the tests in Rust. And as you can see, let's scroll through quickly. As you can see here, there are a lot more tests again. And the tests are very small. And small tests become more readable then, because we don't have to parse so much code and ask ourselves what's going on here. So these are all the tests just for what? What is this class? Oh, just for the updater. So as you can see, a lot of tests and just for the updater, and none of those tests use real infrastructure. So they don't actually access a database. They don't actually make network connections. And that makes those tests really fast and really stable. So it does this again with a nullability pattern. And let's just take this test here, for example, write multiple peers. So we define which endpoints we are connected to. So these are just socket addresses. Test endpoint 1 is just a socket address. We define which peers are already in the database, and this is just a vector, again, of socket addresses. And then we run our peer history code, and this is again a helper function. And James Shore calls this technique signature shielding. So what we do here is we have a helper function that runs the code we want to test, and that way we can just change the signature of the code we want to test. So we can add more arguments that are required, we can change stuff, and we don't have to update the tests. So this is a layer of abstraction here so that our tests are protected from changes to the production code, signature changes. So James Shore calls this signature shielding, and that's what we do here. Signature shielding so that our tests don't have to be changed when the production code is changes. Where was the test? So yeah, so we run our updater, peer history updater, and it returns us a vector of the written socket addresses which got written to the database. It returns as a vector of the deleted socket addresses which got deleted from the database. And then we can assert that these 3 endpoints were written to the database and that none were deleted. And we can also, so this is also usually very hard to test when you use real production, the real production code. It not just inserts the endpoint into the database, it also inserts the timestamp, the current timestamp of now. And whenever you write tests that involve the current time, those tests are usually brittle or it's hard to write because the time changes all of the time. And how did we fix that? With nullable time. So let's just show you how the nullable time works. Here I have created the system time factory, and the system time factory has a now function which returns the current time. And we have 2 strategies here. We can either use a real system time factory in the real production code, which returns just the current system time, or we can say we want to null the system time factory, and it returns a configured value. And with that, we can now write tests, and we know exactly the time that our system time factory returns. And that makes it possible for us to write tests like here, where we actually assert the time. So here we create a test time, and then later on we assert that the inserted endpoints were inserted with this timestamp, with this exact timestamp, and this cannot fail. So with this technique, we can write tests that involve the current time, and those tests are not brittle at all. LFLF says, do you make sure the actual resources act the same as the nullable ones? Yes, I do. And I want to show you that. For example, the nullable database could read values differently from the real database because of a bug. Yeah, and that's why I wrote tests for that. So let's go to the nullable database. So here's the ledger with a null builder. Let's go to the peers table. Peers store. So this is the peer store is the struct that is, it's like the repository pattern. It accesses the underlying database to read the peer store stuff. And there is no stubbing in here at all. So the stubbing is at the heart, so at the lowest level, and the lowest level is the LMDB environment. And I used a crate here, LMDB, the LMDB's crate. And I wrote a thin wrapper, which again has two strategies. Let's scroll down. So it has two strategies there. It has the real wrapper, the real LMDB stuff, and it has the null version, which just returns the stubbed values. And so this is the real code. It just delegates all calls to the LMDB crate. And this is the stubbed implementation, which just returns the configured responses. And I do have tests for this. And I have, for example, where are the tests? Here, we have some tests here. Yeah, so this test here, so this is the test for the cursor. In LMDB you can get a cursor and you can use the cursor for reading data. And this test here creates a real, I call this function create real LMDB ENV. So this creates a real file. And then it uses our LMDB wrapper code to open that file and to read some data. And this is what James Shore calls, what does he call it? Thin integration? No. Thin integration test or something like that. So this is the only place, or one of the only places, where we actually talk to a database. And then for all of the other code in our project, we never have to do that ever again. So this just makes sure that our wrapper code behaves the way we expect it to do. And then we have nullability tests where we test that our nulled LMDB environment behaves the exact same, as you can see here. So this is just like tests for nulled read cursors for LMDB. And yeah, this is work, and it takes some time to write this stuff. But the good thing is you write it once, and then it is highly reusable. So the only thing that is stopped is the LMDB low-level things like the cursor or the transaction. For example, here this is the read-only transaction. So you have to write this stuff once, yeah. But then all of the database code in all of the Nano project can just reuse that, and I never have to worry about writing stubs or mocks. So I can just reuse that in the tests immediately without any extra work. LFL says, cool, thanks for the insights. And Anafnot says, I love your tests, it is really great. What would be your recommendation to start with this type of testing in legacy code? I don't have the luxury to start a greenfield project. Me neither. I mean, Nano isn't a greenfield project and it is legacy code. At least Nano has tests. So that is really good that Nano has tests. But as you know, I am not happy with those tests because they are not real unit tests. They are integration tests. And hard to understand how to write and flaky. Again, like just look at this peer history restart test. this huge thing that tests that when a node restarts, that it connects to the stored nodes. And now just look at the tests that we have here in Rust. And those tests are just a lot smaller, easier to write, and they are not flaky at all. So, and super fast. Yeah, and oh yeah, one thing. No, let's just one thing after the other. Let's just go back to the question. So, what would be your recommendation to start with this type of testing? Yeah, you just have to start somewhere. I mean, if you can start at the very bottom, so introduce nullability at the very bottom, and then you could work your way up. But if this is not feasible, I think even James Shaw wrote about this. I think he said also like try it from bottom up. But if it's not feasible, just start at a class in the middle and make it nullable, or make it stubbable really. Nullable with an embedded stub, and then later you could just remove that embedded stub again and go one level deeper. And this is wasteful because you would write stubs that you would later throw away. But maybe this, yeah, it depends. So there is no one answer that fits all. Andeflan says, I had to fix tests that failed always from 1 o'clock to 2 o'clock. That was fun. I had that too. Like I was in a project, and when you ran the test suite and it was after, I don't know, 11 o'clock, it just failed. Because it used the real time somewhere, and there was a business rule that didn't allow something to happen after 11 o'clock. And that made the test fail. Yeah, that's just, yeah, that's crazy. And that's why we want to be in control. We want to be in control of the time. We want to use a nullable time. Nobody from team pushed to repo after midnight because of that. Yeah. Oh, it's also a healthy work habit then. You don't work too much. Yeah, so that was these tests. And oh, and one thing is missing still. So because we have a lot of very detailed tests here that make sure that our cached peers are connected to. But there is one important thing that we haven't tested, and that is that we actually run this code when we start a node. And we need tests for that, because we could, yeah, this line that runs the node, it could be deleted and nobody would notice. So let's go to the node RS file. And let's have a look at how we did that. So the node RS file is horrible, by the way, and it's on purpose, so I'm going to clean this up. And yeah, let's just, can you see that, chat? It's just a mess, like 2,000 lines of many clones, ARC clones and whatever, and all of those, most of those ARC clones will disappear in the future. So let's just scroll through this mess. And let's go back up again. So this is the node struct, and somewhere in here it has, yeah, somewhere in here it has the peer cache connector. Here it is. LF says your test obsession is on another level. It gives me a whole new perspective. Yeah, it is. It is. I know, guys. I know I'm very pedantic when it comes to tests, But yeah, I know there are other peoples out there who are even more pedantic than me, and I would say James Shaw is more pedantic than me when it comes to testing. But also I have to say that being pedantic about tests really helps me in my profession. So whenever I write code and I also write code with the rule that I am not allowed to write any production code without a failing test. So this is actually the way test-driven development is defined. You are not allowed to write any production code unless you have a failing test. And most people who write tests don't do that. So they write production code and afterwards they add a couple of tests. And that's better than no tests, but I am very pedantic about this, and I believe that you can never be sure that you've tested everything, and you can never be sure that your tests work correctly if you don't work in that style. And yeah, I'm hardcore. Sorry, guys, I am. And but I don't expect others to be like that. It's just the way I am, and I think it is a good way to work like that in this style. Because usually you have hardly any bugs when you write code like that. And when you want to change stuff, you can do that very quickly because you have everything tested. Now says, never knew someone who tests log messages. Yeah. I didn't, and I started testing log messages only 1 or 2 years ago. And I've been programming for, I don't know, over 30 years. So I started doing that only 2 years ago. Or 3. But I want to keep it. So yeah, you don't have to test log messages, but I want log messages to be correct. So that's why I test them. Oh yeah, so here we have the Peer Cache connector, and that is the code that we have tested extensively, but we have not tested that this is actually called. So let's go to the place where we actually run this. So here it is initialized, and then we have the node start function, which starts all of those threads, and somewhere down here it calls Peer Cache connector.start, and we could just, by mistake, delete that line. And if we don't have tests that catch this, then it's bad. It's a bad situation. We want to make sure that our Peer Cache connector is started with a test. And let's scroll down there and let's see how it's done. Here, start Peer Cache connector. So there's a test that tests this, and this is not at the level that I want it to be, but we have to do compromises sometimes because the code isn't there yet. So what it does is it creates this node, and Bitcoin network is not producing blocks again. Oh no. Is it time for a new giveaway? When did I give away the last nano? Oh. It's time for a new giveaway. Elibob, congratulations. So 1 nano for you. Timer's running again. Yeah, but that's Bitcoin. I mean, Bitcoin sometimes has, has an hour or two without a block. That's why we work in Nano. Yeah, so the start Peer Cache connector. So it calls the node start function, and yeah, so the thread that is started, it has output tracking, also a pattern from James Shore from Nullability, so we can track when start is called. So this is the embedded observability. So we call node.start, and then we assert that our start tracker has one event in it, a timer started event, and we assert that the thread name is correct, we assert that the interval is correct, and that it should run immediately. So that's how we test that. So, and I think this is the very difference here. So while the C++ code tests everything through the node, everything through the top level, we test everything at the lower levels, and then the only thing that we test at the top level is that stuff is connected correctly. So we are just testing here that our peer cache connector got started. That's the only thing we test. And we don't test what it does. We test what it does in the lower levels. And here we just test that we started it. And in this style, we get a full test coverage, and we find everything that could go wrong, really. And we can write the lower level details tests easily. And the tests become small and fast, and you know. So LFLF says, doesn't this test methodology introduce a lot of boilerplate? What else would you need? Track start, for example. Yeah, it adds boilerplate. It does, but it's the price that you have to pay for writing those simple tests. So nothing comes for free. So everything has its price. And writing tests like that, you have to add boilerplate. So let's have a look at the track start. It is not much code, really. So I copied that code, or I adapted that code from James Shore with the output tracker. So I wrote this output tracker things once. So this is just one struct, and it is generic. And I can just use that. And it's just a handful of lines, really. So the start listener is here. We initialize it in the constructor. And when we call track start, it just delegates to this listener. And whenever we start the thread, we emit an event with the data. So that's it. It is not much boilerplate from my perspective, but it is more code, yeah. And you end up having test code in your production code, or not test code. You have the nullability, the embedded stub in your production code, and you have the observability, these output trackers here in your production code. And I have no problem with that at all. I know some people have problem with that, but I don't think this is wrong on any level. Alster Ripe asks, where should I start to end up being a developer like you? Practice. And no, I think the most important thing is to have fun. Really, like I deeply enjoy this, and that's why I've been doing this for so long. So this is the number one thing. It should be lots of fun. And to keep an open mind, because you never know everything, and there's always plenty of ways to do things. And if you learn from other developers, like I do this even today, I watch a lot of other developers code. You always learn something new. So, okay. How late is it? Oh my god. Stream is all... we are already over 50% of the stream. We haven't written any code yet. But I think this is interesting. What do you think, chat? Any more questions or comments? Opinions? Yeah. Yeah, here you can see I wrote a test for that this tracking actually works. So no, this is another tracking. This is tracking of the cancellation. So I usually test all of that tracking and stopping code too, because I want to make sure that this actually works. And I like my tests to be small. So I don't want to have tests like here in the C++ code where I have to scroll through and where I have to sit down and study hard to know what it does. Like, so what does this test do? And then you just get bombarded with so many lines, and you have to read through all of them and find out what this test does. really, I don't like that at all. So I want my tests to be really small, so that I can quickly grasp what's going on, and I can quickly write new tests for everything. Yeah. Damiasco says, very interesting. Alsteripe says, just thanks for the motivation and for the hard work. Yeah. Thank you guys for the support. I don't see it as hard work, really. It's a passion, really. So other people's, I don't know, play football or whatever, and this is my passion. So yeah. So what can we do now? I showed you. Is there anything else I wanted to show you? Let me quickly check. No, that's it. So we have a bit of time left, a bit less than an hour. We could work on making the code nicer. For example, the node itself. We are in the node file already. So this node struct is huge. Like I said, 1,800 lines of code. A lot of stuff going on in here. And I like the node to be just the top level thing that creates the lower level things and that connects them. And that's it. That's how I see the node struct. It just is the top level thing that manages the lower level things, and it just connects them and creates them and starts them. And it doesn't do that right now. It has logic in there, like low level stuff. For example, this function, ongoing bootstrap. And what it does is, I think it just tries to bootstrap periodically. And as you can see here, it is just full of logic there and low-level stuff. And that shouldn't be in the node. That should be in its own class that we can individually test. Same for ongoing ledger pruning. So what this does is it prunes the ledger. If you enable ledger pruning, it will just delete blocks that can safely be deleted. And here again, ledger pruning, low-level stuff. Online, what is this? Ongoing online weight calculation queue. Backup wallet. Yeah. So I want all of those. I want all of those to be in their separate files that I can test individually. And the node should just call into that. The node should not have those things here. And the biggest beast is this one, ongoing bootstrap. What a huge thing this is. So I would like to move this out of the node and into its own file so that I can write tests for it. Maybe we could start there. Bootstrap, ongoing bootstrap. Let's create a new file. Let's create a new file, but where? Does this belong to bootstrapping? So I think I have a bootstrap folder here. A lot of things in there already. Let's create a new one. And how do we call this? So what does this code do? Let's just have a look at it again. The fella says Gustav will be the first person to achieve 200% test coverage. What's your experience, NanoFam? Have you ever worked test-driven? Are you developers even? So I suspect most of you are, because this is just a very code-centric stream. So I suppose most of you are devs, aren't you? Have you worked test-driven, or have you written unit tests, or do you usually not write any tests? What's your style and what's your experience? I'm curious. Do you think this is utterly stupid what I'm doing here? Like really, I want to know. Ongoing bootstrap. So it LFLF says our project's test coverage is at 3%. Writing unit tests is discouraged. Yeah, and it is really tough. Like if you work in a project that doesn't have tests, then it is really hard. So the barrier is even higher then. If you start with a fresh project and you start test driven, it's not, yeah, it's a lot less difficult. Sammy D says, my company always skips on unit testing. And Andefnal says, yes, I wrote tests for old, not tested code. Oh yeah, that's also not fun. I tried TDD, but I'm so slow. Yeah, it is so normal. It is normal to be slow. And also, don't trust that feeling so much, because again, like working test-driven feels slow because you take much more time to get the initial code out. But you save that time later on. You save that time by not debugging, by not having bugs. Yeah, and you save that time by being able to change the code later on quickly. I mean, how would you even refactor? How would you refactor code if you don't have tests? You would just hope. I mean, you can't just test everything by hand for every change you make. And the alternative to not test, to just hope that things are all right, that's not a good strategy, and it never works. Like we always make mistakes. We are humans. I make the dumbest mistakes when I write code every day. Even after 30 years, I make the dumbest mistakes. And the fellow says, at least I'm happier knowing that I won't break it so easily. Yeah, that's true. Damiasco says, as a web developer, primarily, what are some projects where Rust shines that I can get into? Would like to learn Rust. As a web developer, I used HTMX, or I'm currently writing for a client a web project with HTMX and Rust, and that works really, really well. So I can only recommend that. I'm using HTMX, and on Rust I'm using Ascama, templating engine Ascama, and then HTTP server. So like what Auxum or Actix Web or something like that. So that combination worked really well for me. And Defnal says, I hope I didn't break it. It's the worst nightmare. Yeah, and then you push it to production, and then your telephone rings in the night. I've had that. LFLF says, our projects run on hope and good intentions. So far it worked out, but I feel so unsure about changes because of it. Yeah, I know that feeling. I've worked in projects like this. And yeah, it's just like stressful. You never know if you... Yeah, every change you make is an adrenaline rush, and you never know if it works, and then you push it out to production, and you just hope that it works, and that's stressful. And a lot of times it just doesn't work. And if Null says, Damiasco, you could write a small CLI for JSON manipulation or something like it. It's not your typical web dev stuff, but it's close, yeah. Yeah, so Rust shines on the backend more, I think. I've worked with WebAssembly stuff, but that is just very unstable. So not from unstable that it crashes. I mean the libraries, they change a lot, so that's a pain. So you write you want to work on something, and then the libraries change all of the time, and you have to constantly yeah, fix the incompatibilities then. And that's why that's why I switched to HTMX, and I have no JavaScript or WebAssembly or anything on the client. Yeah. Let's cheers one more time to the full Rust node. Okay, so yeah, I wanted to move this ongoing Bootstrap code out of the node. HTMX, Andefnal says, Gustav, who influenced you with that HTMX? Oh, it was the Primeagen, of course. Like, he kept talking about HTMX over and over again until I had a look at it, and I thought, yeah, that seems like a very simple approach, and it has to fit your project. It is not a silver bullet for every web project, but it was a good fit for what I'm currently working on for a client of mine, and yeah, and it is just a lot simpler than having a full-blown React whatever JavaScript client on the browser. I forgot the timer again. Oh my, no, I didn't. So it's time for another giveaway. Craptor. Congratulations. Oh, I have to push out all of the nanos in the end again, like last stream, because I constantly forget to start the timer, or I don't hear it when the timer is over. Rigged, of course, yeah. You know what, guys, let's spin it again. We have only given away 4 nanos so far, and we have only 45 minutes left. Let's just spin the wheel one more time. And this time it's Pies. Congratulations, Pies. Okay. So, ongoing Bootstrap. How can we name the struct that we want to move this code to? It is ongoing, so it is... What does that even mean? It is... okay, so there's a next wake up. Okay, so there's an interval. Network bootstrap interval. Bootstrap interval. And then it does something in here. So let's call this... What is this? Bootstrap, ongoing Bootstrap. Let's just call it ongoing Bootstrap, and for the lack of a better name, I can always rename it. Craptor says, I was starting to run low on nano on my spending wallet, so nice to get refill. Yeah, it's free refill today. So let's call this ongoing Bootstrap. And oh, you guys don't see that. So ongoing Bootstrap. And let's go to the node rs, and let's, so maybe we can just copy that. Let's, yeah, why not? Let's just copy everything. For ongoing Bootstrap. And let's just copy all of that. And this, of course, will, oh yeah, a lot of errors, cause a lot of errors. So let's just import the missing stuff. Oh, restart this LSP. Ongoing. Bootstrap. So we have a duration. Come on. Duration. Ordering. Network params. Let's also add that here. Network. And this is network params. Warmed up. What is that? Atomic U32. Okay, let's copy that. Then we need the Bootstrap initiator. And it's still all arcs. And that's okay. It won't stay like that. I have to keep it like that because the tests are still in C++. And currently arcs are the way we make sure that C++ and Rust can communicate. And this will change. I made a prototype. Want to see it? NanoFam? I made a very small prototype of how I want to have the node startup without arcs. And it is in... No, in which folder is it? Temp. No? Temp? Here, run node spike. Yeah, this is how I want to do it. So I want to just create the parts, and then I want to use the thread scope, the scoped threads, to spawn the things that should run, and I also want to use that to spawn the Tokyo, so the async stuff, and all of that is scoped, and that means we never have to use arcs. And yeah, so this is just a sketch that I tried out and it works. And the nice thing, so this here is basically the start. What currently our this is the node.start. And the nice thing is we don't need a node.stop. So stopping automatically works. So whenever we want to stop the node, this whole block waits until all threads are exited, and only then it returns. So we never have to call stop for all of those threads here. Like in the C++ code, we can just skip that step then, and it just takes away one more thing that we could do wrong. Yeah, so let's close that again. Okay, so warmed up. Then we need the channels. And we don't have to make it perfect. So this is of course far from perfect. We just improve it in small steps. And as long as we keep doing that, the code will be really nice eventually. Flags. So flags is node flags. And what else is needed? The ledger is needed. Everything is an arc right now. And what else? Stats. Okay, stats. Underflown says, I know Arc Mutex is bad, but I have no clue what that scope thing was. Yeah, so firstly, I wouldn't say Arc Mutex is bad because there are legitimate cases where you need it. But what you see here, this is really bad. The way we use it here, this is really bad because everything is an arc. Check this out. Everything is an arc. We just have arcs everywhere. And this is bad because it bypasses the borrow checker. So one of the strongest feature of Rust, the borrow checker, we disable it while using these arcs. And it is so easy to introduce memory leaks with arcs. And when we would use the borrow checker instead, we wouldn't have those problems. Yeah, but it is temporary. So we are going to get rid of all of those arcs, most of those arcs. And the scope thing, yeah, let's just go back to the scope thing. It is not that difficult, actually. Let's go back to that. This is a new feature in Rust. Which version was it? Introduced a couple of months ago. What thread.scope it allows, so it follows a block here. So everything in this block here, we can spawn multiple threads. Maybe let's just delete the Tokyo stuff because this complicates things. So you can just spawn multiple threads in here. And the cool thing with the scope threads is that the thread itself here, it can borrow stuff from outside here. So the ledger, the lifetime of the ledger is from here to the bottom. And when here we start the thread and we don't move ownership into the thread. So we don't have a move here. We just borrow ownership. We just borrow. So we borrow the ledger and we call run. And same for the block processor. We just borrow the block processor. And those threads, they run until they are finished. And the whole thread scope will wait for all spawn threads to finish. And only when all have finished, it will return. And that's fantastic because it allows us to use the borrow checker. So we just have the ledger. We don't have an arc ledger here. We just have the ledger, and the ledger will go out of scope down here. So it will be destroyed after the threads are done with its work. So that's exactly what we need. That's exactly what we need to have to get rid of all of the arcs. I hope that made things a bit clearer. Okay, let's go back here. And let's include the stat type and the detail type, the direction. What else? The Unix epoch. The system time. What is that? We also have to import that trait, yeah. Okay. Account. Let's import account. Okay, and that's the last bit. So we need the workers. And what is this? Downgrade self. And then it's calling ongoing bootstrap again. I want to change all of that code to do what Piotr suggested recently. I think yesterday, or Piotr posted about this. maybe he didn't even post about this publicly, but he said that this pattern where we use the worker thread pool for our periodic tasks, and we just push task into the worker thread pool, he said that he didn't like it, and I agree. He said it would be better if this would be just a dedicated thread where we would use our condition variables to wait for the timeout. And this is what I want to do here. So, but I don't want to get entangled into too many changes at once. So maybe I can keep it. Yeah, let's do it one step after another. I want to keep it like it is, but because this makes a weak pointer out of self, means that this code can only run if our ongoing bootstrap is in an arc, inside an arc. So let's define a trait here. Ongoing bootstrap ext, and this will get the ongoing bootstrap function. And then we implement this for arc ongoing bootstrap. Like that. And then we can just move that code down there. Not all traits are what? What's wrong? Ongoing bootstrap. Non-item in item list. Non-item starts here. Oh, the opening brace twice. Okay, so now we need the workers. Workers is an arc. Thread pool. What is it? Thread pool arc. Is it this? Wenderson is here. Nano is the light. Congratulations. Thank you, Wenderson. Thank you so much. Let me put you on the spinner wheel. Oh, it's again time. I have to fix this. I don't get a sound notification anymore when the time is over. So, Wenderson, you are just in time. Wenderson, congratulations. You come into the chat and you immediately win 1 nano. Okay. Okay, timer's running. Congrats, Wenderson, yeah. So what else do we have here? No more errors. So this is, it looks like this compiles. So let's use this ongoing bootstrap now in our node. And how do we do that? We just create it, or we just, let's add it as a field. Ongoing bootstrap arc ongoing. Oh, I have to make the ongoing bootstrap public. Okay. And now let's initialize it somewhere in this huge code block. Let's just go down, down, down. Here maybe. So that's ongoing bootstrap. Is arc new. Oh, we don't have a new function yet. Let's create that.